Hey everyone, and welcome. So you've probably written a for loop in Python, right? The classic way to build a list. That's kind of like Python 101. But what if I told you there's a whole other level, a world of tools already built into the language that can take your code from just working to actually singing? Today, we're going to dive in and see how we can write smarter, faster, and way more elegant Python.
So let's get real for a second. Think about your code. It works, right? But is it as elegant and efficient as it could be? I'm talking about writing Pythonic code. And that's not just some buzzword. It means writing code that's, well, it's the way Python wants to be written. It's clean, it's readable, and it's efficient. It's really the difference between just getting the job done and being a true craftsperson with your code.
And check this out. This is a perfect example of what I'm talking about. On the left, you've got the classic for loop. 3 lines of code. It totally works. Nothing wrong with it. We've all written it a million times. But look at the right. That's the Pythonic way. A single, beautiful line called a list comprehension. It does the exact same thing, but it's so much more direct. It tells you its intent right away. Hey, I'm making a new list based on this other thing. So much cleaner.
And you might be thinking, okay, that's a cool trick, but it's not a trick. This isn't some secret advanced feature. These incredibly powerful tools are already baked right into the Python data structures you're using every single day. We're just going to unlock the power that's already there.
You know, comprehensions are way more than just a fancy shortcut for a loop. You can actually stick an if statement right in there to filter stuff as you go. Super useful. And get this, you can even nest them. That means you can do some really powerful stuff like, I don't know, transposing a whole matrix of data in one line of code. It's crazy. And the best part, it's not just that the computer runs it faster, it's often way faster for you to read and understand what's going on.
All right, let's switch gears to dictionaries for a sec. You know how you can call .keys or .values on a dictionary? Well, in modern Python, that doesn't just give you a static copy of the data. No, it gives you something much cooler, a view. Think of it like a live window looking directly into your dictionary. If you add or remove something from the dictionary, the view updates automatically, instantly. And the real magic here is that it doesn't copy all that data. So if you're working with a massive dictionary, this is a huge win for memory efficiency. It's a game changer.
Okay, so we've talked about the built-in stuff, but Python also gives us a special toolbox called the collections module. If you think of lists and dictionaries as your basic everyday screwdrivers, you can do a lot with them, then collections is like opening up a chest of specialized power tools. Each one is perfectly designed to do one specific job and do it incredibly well.
First tool out of the box is counter. And I gotta say, this one's a personal favorite of mine. Just think of it as a tally machine on steroids. Its whole purpose in life is to count things. Words, numbers, whatever. And it's insanely good at it. Seriously, if you ever find yourself starting to write a for loop just to count how many times something appears in a list, just stop. Reach for counter instead.
And look how easy this is. You just import it, feed it your list of words, and bam! Instant results. You get this dictionary-like thing back that has all your counts perfectly tallied up for you. No more writing loops, no more if key and dict checks, just one simple, super readable line. It's beautiful.
All right, next up, we have default dictionary. This thing is your best friend when you're trying to avoid that dreaded key error. You know the drill, right? You're trying to group things into a dictionary, so you have to write that clunky code. If the key isn't there, create an empty list, then append. Default dictionary just throws all of that boilerplate out the window. It automatically creates a default value for you, like an empty list, the very first time you try to access a key that doesn't exist. It's a lifesaver.
Let's take a look at it in action. So here, we're trying to group this list of tuples by their key. We just created default dictionary and tell it, hey, if you ever see a new key, just make its value an empty list for me. And now look at that loop. We can just append. No checks, no if statements, no nothing. It just works. This makes grouping data so clean.
Okay, moving on to deque. It's a weird-looking word, right? It's pronounced deque, and it's short for double-ended queue. Basically, it's like a list that's been put through a super soldier program. It's been hyper-optimized for one thing, adding and removing items from both ends, the front and the back, super fast. This makes it the absolute perfect tool for building things like queues, or if you need to keep track of, say, the last 10 items in a stream of data.
But why not just use a list? Well, here's the crucial difference: performance. If you try to pop an item from the front of a regular list, Python has to physically shift every single other element one spot to the left. If you have a million items, that's a million shifts. It's incredibly slow. A deque, on the other hand, is built differently under the hood.
Popping from the left is what we call an O1 or constant time operation. It doesn't matter if it has 10 items or 10 million, it takes the same tiny amount of time. It is lightning fast.
Last but not least in our toolbox, we have namedtuple. This thing is awesome. It's for when you need a simple way to bundle some data together, but you don't want to go through the whole ceremony of creating a full-blown class. So instead of having to remember that the user's ID is at index 0 and their email is at index 1, you can just do user.id and user.email. It makes your code so much more readable, it's practically self-documenting.
All right, so we've seen all these cool tools. But theory is one thing. Let's see how they perform in the real world, under pressure. We're going to dive into a case study about a web analytics company that was quite literally drowning in data.
So picture this. You've got this company, and every single day, they're trying to process millions of log entries. Their original scripts were built the old way, just basic for loops and standard dictionaries, and the whole system was just choking. The scripts were painfully slow, they were eating up a ton of memory, and the worst part, their dashboards, the whole point of this exercise, were constantly lagging behind reality.
So, the team went in and completely refactored the code using the exact tools we've been talking about. First, they took those messy raw log lines and used namedtuple to turn them into clean, structured objects. Much better. Next, they fed those objects straight into a counter to get instant counts of unique visitors, error codes, you name it. And finally, they used a default deque to effortlessly group all the page views by user. See how each tool fits perfectly into the pipeline? It's like a well-oiled machine. And the results? Well, they were pretty staggering. The new script was 40% faster, and it used 25% less memory. Think about that. Just by swapping out the generic tools for the right specialized ones, they got this huge win. No crazy new algorithms, just using the right tool for the job.
But, a 40% reduction is just a number. What does that actually mean for the business? It meant their dashboards could update every 5 minutes instead of every 30. That is a massive difference. They went from looking at old data to seeing what was happening almost in real time. They could spot problems, see trends, and react instantly. That's the real-world impact of writing smarter code.
Okay, so we've seen the tools, we've seen what they can do. Now, the big question is, what about you? It's time to start thinking about your own projects. Where could you use these ideas? Let's move from just learning about this stuff to actually building with it.
So let's recap your new Python toolbox. When you need to build a list, think comprehension. Need to count stuff? Counter is your go-to. Grouping data? Default deque all the way. Need an efficient queue? That's a job for deque. And for simple, readable data records, namedtuple. Remember, these aren't just for looking clever. They make your code better, cleaner, faster, and way easier for the next person to understand. I want to leave you with one final thought. It's easy to write code that just works. Functional code gets the job done. But is your code telling the best story it can? Is it clearly communicating your intent? Using the right tools isn't just about shaving off a few milliseconds. It's about elevating your craft. It's about making your code a clear, powerful, and elegant expression of your ideas. Thanks for watching.